starting. All right, somebody said, whoa. Maybe it's because this cardinal here is very handsome, dashing cardinal. Some probability for you. All right, welcome back to Study Hall, January 14th. Recording has just been started. Again, let's show that copyright notice there. All these problems are from free GMAT prep software, which is copyright GMAC. Yes, it is. Freeware, free distribution, that whole bit. Okay, let's do one. Let's do a problem. And how about this one right here? Okay, don't forget that's where your multiple choice questions are. Give it a shot. All right, we should be picking an answer pretty soon. I'm not going to put the timer up there because having a timer in front of you is a very bad habit. Like that builds dependence on the timer, which is totally, absolutely not what you should have. I mean, remember what time management is in this exam. I mean, time management is just, are you stuck or are you not stuck? And if you're stuck, you quit what you're doing. The timer should not be something that you ever really have to look at. So it would be bad form to stick a timer in front of your face. All right, let's pick a thing. Alexander, DL, DR, Ginny, KK, Lily, William. Okay, well, we got a few non-responses here, but we got to move on with this. So here's what we have. We got two answers that are very popular here, but notice that they are not anywhere close to each other. I mean, people like this answer and people like this answer. Remember, this is a problem about the real world. I mean, probability is a little bit of an abstraction, that's true. I mean, probability is not the most concrete thing in the whole world. But this question is still totally about a real life situation. What does that mean we should do first? Like in any problem that's about a real world situation, I mean, what should we maybe draw it out if you can? I mean, this question, maybe you can figure out a way to draw it if you're a more visual type of person. But I mean, like any question at all that is about real world stuff and then has an answer that is in the real world. I mean, here's a really stupid example, but about this. Okay, what's the answer to that, y'all? It's B. Hey, how about that? How do you know that? Do you know that because you are amazingly good at guessing my exact age by listening to my voice? Is that how you did that? I mean, if you were that good, that'd be impressive, but aha, because the other answers are stupid. That's basically the point. I mean, I'm obviously not 8, and I'm obviously not 502 either. So that leaves us with one answer that's not completely crazy ridiculous. And that's what you should do. I mean, because in the real world, this is what everybody does all the time. Like if you're doing a recipe or something and you need a certain amount of, I don't know, certain amount of flour to bake some cake. I mean, you probably have a rough idea of how much you need. And if you need to make one cake and you get like 55 pounds of flour that you need, probably not right. You know, you made a mistake somewhere. And really, like, this is what you should do. In every real world problem, absolutely every single one. Every real world problem. I mean, always, if you can, get a common sense estimate of the answer and eliminate choices that are ridiculous on planet Earth. Okay, well, you know, let's talk about this for a second. And we have 6 people who work at this shop. And we want to know the probability that we pick exactly these 2 people out of the 6. So somebody tell me about that. Is that going to be super likely? Like, another way to think about this, let's say that you're with your girlfriend or boyfriend, wife, husband, whatever, right? I mean, yeah, you need to be picked to go on stage for some kind of game show or something like that, and there's 6 of you left. I mean, if you think about it, randomly choosing 2 out of 6, they're not going to pick you guys 1/3 of the time. I mean, because they're just not. I mean, you can just kind of think about that in your head. You know, I mean, there's a lot more than 3 ways to pick a pair of people here. So this is just not a likely thing at all. I mean, because maybe if you picked E, maybe you were misreading a question. Because, like, if you wanted the probability that either Jose or Joshua gets picked, then that would be more reasonable figure. Because, you know, there's only 6 people, so if you have 2 designated people, then it's decently likely that at least one of them is going to be chosen. But that's not what the question says. The question is, what is the probability that both of them will be chosen? Should be clear just by using common sense that this is a relatively unlikely event. Right? I mean, we're not doing any math there. You're just kind of thinking about it. This isn't that likely. I mean, smiley face, if that makes sense intuitively. And remember, this is what you should be doing. In the real world, this would happen right away, immediately. Like, if you saw me in the real world and it was like, how old is Ron? You would kind of just size me up and you'd be like, okay, well, he's between 35 and 45. And then you would try to figure it out. Only once you had some sort of figure in mind, right? So, not very likely. Certainly not 1/3. No flipping way, right? And also, well, you know, 1/6 probably still seems a little bit high. But it should be clear at least that 1/3 is just not a reasonable thing. And then, yeah, 1/6 also. The other reason you shouldn't terribly like 1/6 is just that they don't really write problems where the answers are made up of numbers that are right there. So if you have 6 workers, and it's not that likely that it's going to be something out of 6. So, okay. But no, nothing. And what this means is if you do math and you think that your math gives you answer E or D here, that means you still don't pick it. Nope. You don't do it. You know, if you're baking a cake and you do a bunch of math that says you need 55 pounds of flour, you don't buy 55 pounds of flour. You're like, dude, I must have made a mistake somewhere. Had to have made a mistake. So it's important, right? Common sense always has to win here. Do not pick the answers that don't make sense. Like, even if your work gives this answer, nope, don't pick it. Because it doesn't make sense. Okay. Let's talk about the problem. So we can get rid of those. All right, let's get rid of those last 2 choices. All right. Now, when it comes to probability questions, there's a way that you can do these, which is, shall we say, severely underutilized. Like, how did you learn about probability when you first learned about it? Probably 6th grade, 7th grade, something like that. How did you learn that? I mean, you might have learned with flipping a coin, rolling dice, something like that, right? But how did you calculate probabilities when you first learned what probabilities were? You made a fraction, and where'd the fraction come from? You definitely weren't doing things like multiplying together other fractions or things like that. No way on 6th grade. I mean, how'd you do that? Where'd the fraction come from? That's where it comes from. Yep. You just count stuff. Is what you do. Not sure what you mean there by expected outcome times total, but that doesn't sound like anything I did in 6th grade. But yeah, you just count stuff. I mean, this is ultimately what probability is. Like, if you don't, and this is really like, if you don't immediately, and where that actually means immediately, if you do not right away think of a way to calculate the probability, just start listing stuff. I mean, there are a lot of problems where the only way to do the problem is to make a list and just count stuff. I mean, there are actually quite a few problems where that is literally the only way to do it. Here, there's other ways that we'll get into, but a lot of people are just leaving these things sitting on the table because they're like staring at it and trying to think of like, what's a cute way to calculate this? I mean, you don't think of a cute way to calculate it. Don't keep going down that road. And let's do that, right? I mean, let's say that, let's just list people. Let's do it, right? 6 workers. Let's say that our 6 workers are just called 1, 2, 3, 4, 5, and 6. And then we have these 2, Joshua and Jose, right? So number 1 can be Joshua. And number 2 can be Jose. Sure. Let's just start listing stuff. Okay. Different ways to pick 2 people. You have 1 and 2. What do you want to list after that? 1 and 3, 1 and 4, 1 and 5, 1 and 6. Then we got, what's 2? Do we need 2 and 1? You could do 2 and 1. You could do it, but there's not really a difference between 2, 1 and 1, 2. So if you do that, you're just going to wind up with a list that is twice as long as it needs to be and just has everything twice in it. So, I mean, you won't get the problem wrong if you do that. You'll still get it right, but your list will be twice as long as you need it to be. So like 2, 3, 2, 4, 2, 5, 2, 6. Then 3, 4. We don't need 3, 2 or 3, 1. Then 4, 5. 4, 6, and then 5, 6. Hey, look at it. That's all the possibilities. That is all the things. This is the kind of list that you should totally be able to make in maybe 15, 20 seconds or less. I mean, this should really not be any effort. Like, should be pretty much 0 effort, and I'd say maybe max 15, 20 seconds. If this requires effort or if it takes you more than 15 to 20 seconds, you need to practice making lists. Not the most exciting thing in the world, not by far, but this is totally not a thing that should be any effort or any significant investment of time. No, I mean, this is one thing, by the way, that the younger you are, the worse you'll probably be at it because of things like Excel existing in your childhood. I mean, like when I was in school, we had paper card catalogs in libraries and stuff, and we did a lot of organizing lists by hand. So, you know, if you're older among applicants, you're probably pretty good at it. But if not, you get practice it. It'd be zero effort. So the only possibility here we want is that Josh is there. Right? So that's 1 and 2 out of 15 possibilities. So we have 1 winning possibility out of 15 possibilities total. Look at that, it's 1 out of 15. Boom. I mean, again, this is the kind of thing that needs to just happen right away. Yes, you can calculate the answer to this problem, but if you don't know how to do that right away, then don't keep trying to do it. Any questions about this method? I'll look at some more calculational methods here in a second. How do you know that they are? Well, the word randomly there tells you that. But the other thing is that they're not gonna, remember there are no trick questions on this test ever, not even sort of. Like if you, that's the more important thing to say that. Like if you ever even sort of think of like, haha, tricky interpretation, immediately go off of that. It's never gonna work like that, ever, 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 ever. I mean, if the problems ever did that, the problems would be exactly counter to what this test is actually all about. I mean, if this test was full of trick questions, it would be a stupid, useless test that business schools would not want. So just keep that in mind. I mean, the problems are not going to be weird and tricky and gotcha and haha. They're definitely not. So that question, I'm not sure what you mean by anagram, but it's a question that was here. You know, so I'm bored. I mean, we don't even need the rest of the words from this question because if the question is that, the answer is no. There you go. Really, I mean, there are no always on this test. That's the whole point of this test. I mean, you can't memorize your way to success on this exam, which is, you know, the whole point of this exam actually is specifically to be memorization proof in that sort of way. So there's not an always, and more importantly and more thoroughly, if you're looking for things that always work, this test will not treat you that well because they don't exist. And the point is just to have lots and lots of ways to solve the problems and to just flip back and forth between them and to be like super, super impatient. Just as many ways as possible. As many approaches as possible to the end of the game. And you need to be super impatient. If something is not working, you just stop doing it, is the way it works. Yeah. So if you don't think of anything else, just start making a list. But, okay. Let's see what we got here. Other ways to do it. Okay. Talk about calculating stuff. Well, so you know that you can multiply probabilities. We know that. We have more than one decision in a row, which is the same thing as simultaneous decisions, really. It doesn't actually make any difference how you perceive this. You can view this as picking both of them at the same time, or you can view it as picking the first one of them and then picking the second one. Ultimately, those are the same. So you can multiply probabilities to things. You can do it. The thing you gotta know about multiplying probabilities, though, is that when you multiply probabilities, order is always accounted for in there, whether you like it or not. So just make sure that you know this. When you multiply probabilities, order always matters. The order of the events is always taken into account. You can't really multiply probabilities together in a way that doesn't do that. So if you have some situation where there are multiple orders possible, it means you have to account for all of them, is what that means. So if something can happen in more than one order, you have to account for all possible orders when you do that. This is the nature of the beast here. I mean, the same thing as when you do combinatorial calculations, when you multiply stuff together, the default is order matters, and that's why you have to divide by all that stuff underneath the fraction to get order to not matter, because just by default it does, right? So, in what orders can this happen? How many different orders are there? We can pick Joshua and Jose. And Shnappa. We want to pick these two gentlemen out of 6 people. 2 different orders. Sure, it's just 2 people. So we can pick Joshua, then Jose. And we can also pick Jose, then Joshua. Sure we can. Multiply probabilities together for those, right? What's the probability of picking Joshua straight up out of 6 people? It's going to be 1 out of 6. And then once you have Josh, you can't pick Joshua again. Joshua has been taken out of the pool. So the probability of picking Jose is 1 out of 5. Yes, indeed it is. So this is 1 over 30. And then it's going to be the same type of calculation here with the other order. So this time the probability of picking Jose is 1 out of 6. And the probability of picking Joshua is 1 out of 5. So we've actually got the same work again. Well, that's pretty neat. And then these are 2 separate things that can happen. So we got to add those together. Just like any other multiple ways of doing something. So if you do that, that's 2 over 30, which is 1 over 15. And there you have it. How about that? Multiplying probabilities, they are not chosen. Why would you want to do that? You might be able to do that, but that would be very complicated for little benefit that I can see. You try it, and when you review the problem, you should do, the goal of all reviewing of all problems should be to collect as many ways as possible of doing this, but that would add a lot of complexity to this problem because, well, here, I mean, let's think about that, right? What would be, I'm going to throw that question back at you. Like, what would you see as the perceived benefit of doing that, of flipping the situation around? Here's the question. Because I'll tell you what I'm afraid the answer is, and I hope the answer is not this, but I'll tell you what I'm afraid it is. I'm afraid the answer is this is just a random method that I like memorized out of a book, and I'm not really thinking about whether it's appropriate. That's what I'm afraid is the answer. So, yeah, as long as you're thinking about that, then you're going to be fine because you will very quickly realize here that that is not going to happen, right? Because if you like, this is a thing that is not complicated. There's only one way for this to happen, which is both of them, right? This is not multiple cases. Whereas the opposite of this would have lots of different ways of happening, right? The negation of this could be neither of them being chosen, but it could also be Joshua but not Jose, and it could also be Jose but not Joshua. And you would actually have to calculate all of these and then combine them all together and then subtract that out of one, which you can still do. I mean, when you review the problem, you might as well try to do that. Just make sure you can walk through all the steps of it. But if you are taking something that is this uncomplicated and it morphs into something that is this complicated, that you should have an instinct of like, whoops, don't want to do that, right? So, I mean, as opposed to if you have a situation where you do simplify the problem, right? Like versus here's another situation here. Like if you have something like, what is the probability that at least one of them is chosen? I mean, now there's a benefit in doing that, right? Because right now this is something that has three different ways to do it, right? This is three ways, where one way is to pick Joshua and not Jose, and a second way would be to pick Jose and not Joshua, and then a third way would be to pick both. But the negation this time would be very much simpler. The negation would just be neither of them. So in this case, you could benefit from doing one minus probability of neither one. So if you're tossing that around in your head, that's good. Just make sure that if you start doing the work and it blossoms into something with like 4 times as much complexity like this, you should be like, nope, abort mission. And then it'd be fine. Like as long as you don't stubbornly stick to something like this, then you'll be all right. And even on top of that, when you review the problem, you may as well just go through all that and make sure that you can do it and get it work. So lots of ways to do it. But again, don't neglect the possibility of just listing out all this stuff, because that is totally also a thing. And a lot of people don't do that enough. Okay. How about this one? Let's see. Let's do one that's fun. There we go. Data sufficiency. Don't forget where the multiple choice questions are. Again, in these study halls, we do assume that you are familiar with the options for data sufficiency. So that's what is going on here. Give it a shot. Okay. definitely picking something by this point. But start with statement 2. Why is that? Like why would it make a difference? Which statement we start with? It's good to follow a protocol that's decently consistent here. I mean, if you want to do statement 2 first, of course you can, because it makes no difference at all, really. But use whatever seems like the easiest hand grip on the problem, so to speak, you should do. But in general procedural stuff like that, it's best to follow a more consistent thing with something like this. But we'll get to both of them. We'll get there. But gotta pick something. Ready, all the people. First half of the alphabet, especially, is being very shy about picking answers. Remember, guys, it's the people who are not picking answers right away who are most interested in your answers. So, give you another 20 or 30 seconds here. Okay, let's talk about it. Does anybody have any instincts about this problem one way or the other? Like, does anybody make a guess here but feel pretty good about it? If you did, then maybe explain a little bit, because there are a couple of things. All right, so that's not really a guess. Okay. If you look at statement 1, see what the other saying. Okay. So you've got the R and the W in the numerators. Where I'm going with this is not even as much thinking as what you all are doing right now. Like whoa, less thinking. I'm just talking about if you had like literally 5 seconds to guess whether this statement was sufficient or not. This first statement here. You have 5 seconds to guess sufficient or not sufficient. What do you think? What do you get? Here's something about this, right? Like, think about the way these problems are made. Like, where do sufficient statements come from, and where do not sufficient statements come from? Like, it's not a symmetrical type of situation. Like, if you are writing these problems, think about how you would make sufficient statements versus how you would make insufficient statements. These are very different things that are not even sort of symmetrical. Like, how are sufficient statements made? Like, if you had to write a problem like this, where would you get those from? Remember that, roughly speaking, sufficient statements are the things that solve the problems. So just in terms of very rough, like, right, if you were gonna create one of these data sufficiency problems, if you wanted to make a sufficient statement, you would actually have to think about what solves this, or like what makes this work, and you would have to actually work that out, right? Sufficient statements are made from, like, they are things that solve the problem, basically. Like, in other words, they emerge sort of organically from the problem. Like you're not responsible for the quadratic formula in this exam, but the quadratic formula is a very good example of a thing that emerges from a problem. Like if this thing that you learned back in high school or whatever it was, right? Like this, you don't make this up, right? This is the formula that solves that. Now, nobody would ever make this up at random. This just emerges from solving. You guys see what I mean, right? Now, how do you make insufficient statements? The insufficient statements come out of the problem by like solving stuff. We have to get them. If you're writing a data, you should do this. You should write some data sufficiency problems because it'll help make these kinds of points that I'm making here. Like where do you have to get insufficient statements from? For the most part. Just have to. Roughly speaking, we're talking about things that don't solve stuff. Things that don't work. I mean, you kind of just have to, like, make them up. Right? I mean, on some level. I mean, if you want something that doesn't solve a problem, you're not going to get that by working it out. Because the whole point is that it doesn't work out. It doesn't even make it at random. That's where you get insufficient statements from. Right, like smiley face if you see what I'm saying here. Because like sufficient statements on some level are going to be statements that emerge from considering this question, or considering is blah 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 greater than other blah blah blah. And so the point here is that this fundamental asymmetry, like consider something like this horrendous, horrible quadratic formula that is right here. The point is that nobody would ever make this up at random. That's the point. Just, nope, no way. Like the things that people make up at random just don't look like this because they just don't. This is so kind of wild and crazy. That it's kind of like when in biology you learn this theory of intelligent design where you like look at the inside of an animal and it's like, wow, that's so complicated that some god must have designed that. It's kind of like that, right? So the point is that no one's going to make this up at random. And that's the heart of this. Because sufficient things wind up looking like this a lot. Because whatever you get from solving the problem, whatever it looks like, is the thing. But no one's going to just go in there and randomly make up stuff like this if you look at it. So the deal is if you need a guessing method, it's actually a pretty reliable guessing method. Surprisingly good guessing method it is. Surprisingly good guessing method. Statements that look weirdly special or complicated are much more likely to be sufficient. So basically, if you look at it and your response is, wow, that totally does not look like someone would ever make that up at random, then probably that means they didn't make it up at random. It probably means it's sufficient. Again, it's a guessing method. I mean, this is not a thing that you should do first. No, it isn't. But, you know, the more you get weirdo stuff that looks like this, the more likely that's going to be. So, there's probably some kind of problem under this severe condition here. I'm going to try to dig this up right now, if I can. The one example I saw the other day, that was a very nice example. I'm going to try to dig it up real quick. Here it is. Okay, yeah. If you have a 16th edition OG, I can't put it on the board right now because it is OG, but look at OG 2016 data sufficiency problem number 142. Absolutely look at it. And if you, let me see, if you only have the previous edition, then that's number, in the previous edition, it's number 127. So, in the 2015 edition. I mean, that's the best example ever of this. Like, there's a statement in that problem. Just look at it on your own time. There's a statement in that problem that is just so wild and crazy that there's just no flippant way, no way that it could be not sufficient. It's almost as crazy as this. So, yeah. So you should suspect that it's sufficient. Yes, it should. I think you should try to solve the problem first. Of course you should. But with something like this, yeah, I'm guessing that's supposed to say it. But the other thing also is that they don't really make you combine stuff in like weird, crazy ways. So the other thing about this problem is that you should, there's no obvious way to combine these at all, which means that you probably are not going to have to. Because again, they don't give you weirdo, crazy, labor-intensive, weirdo problems. So, like, I literally don't see any possible way that you could combine these, which means they're probably not, you're not going to have to in the first place. So, remember, these problems are a reasonable amount of work. They're not crazy and they don't require, like, obscure genius steps. So you should also strongly suspect that it's not CRE. So if you had to guess on this, A would be a very good guess. But okay, let's talk about it. Let's talk about it. All right, so we have just black and white and red marbles in the jar. So we should probably write this question in math notation, right? How we do that? What is the probability of picking a red marble? Can we simplify that question? Yeah, if you want to write it out directly, then you can, like without simplifying it, you can. Like you have a denominator of B plus W plus R. Yeah, it's going to be that, right? Because I mean, probability being greater of one or the other is the same as having more of those. I mean, you can see that if you write this expression out, you can pretty much see right away that you can multiply out that denominator. So shouldn't, you know, even if you don't think of it right away, it's kind of one of those smack yourself in the head sort of things. But yeah, I mean, if you have a probability that's greater of picking one of these things, it just means you have more of it. So is R greater than W is the real question here. So whether you got there directly or whether you got there by putting this first, doesn't really matter as long as you get there. So that's what we want to know. All right, well, Thomas said something about statement 2 first. Hey, why not, right? That B minus W is greater than R. First, let's make sure we know what the goal is, right? I mean, same as with any yes-no question, there's like a million zillion of these study hall sessions about this, but you have a yes possibility, which is you actually, the yes possibility here would be that R is actually greater than W. And then the no possibility would be everything else, so less than or equal to 1, right? So you can do that. And then you can make both of these happen, and that's not sufficient. Again, if this is unclear what's happening here, then loads and loads of sessions about yes-no data sufficiency. I think there's like 4 or 5 of these, so check it out. But if you can make both of these things happen, then that's not sufficient. Okay, that's what we're trying to do. So we have statement 1, we have statement 2, and then if we have to combine them later, we can do that. So this. Remember, these can be any integers at all. Like there's no restrictions on these. Nope, no restrictions. Someone give me values of B and W and R. Remember your first, you can't have half a marble, man. But we can do 2 and 1 and 1, maybe. Yeah, let's go 10.5, right? Sure, why not? Okay. And then 10 minus 4 is greater than 5. Make sure that you check this is actually true, right? 10 minus 4 greater than 5. So, yeah, you still can't have half a red marble, man. These got to be integers, right? Because they're numbers of things. You can always just double those numbers. They'd be fine. But all right, so here R is greater than W. So we have this. Once we make that happen, our only goal in life is to turn around and make R not greater than W. So that would work if we just take those numbers. That's I'm not even going to try to say that. But if we double your numbers, then we get 4 and 2 and 1. And 4 minus 2 is definitely greater than 1. So again, here 5 is greater than 4, but 1 is not greater than 2. So not sufficient. That's for statement 2, actually. Wink. Just kidding. All right. Smiley face, if that makes sense, what just happened there. All right. What about the other statement? What do you think of that? What makes you try with that if you really don't have any other idea what to do? What could you try to do with that? Statement 1. All right, let's try to rewrite. You mean like doing what with it? Well, no, you can't do that. When you try to do things with variables, you should do a sanity check with regular numbers, because if it doesn't pass the sanity check, then nope. Like this is, you cannot split up denominators like this. I mean, for instance, if I give you 1 over, I don't know, like 1 plus 2 plus 3. I mean, that's a sixth. It's a really small fraction. Whereas this would be, the way you've got that there, you'd be telling me that that's 1 over 1 plus 1 over 2 plus 3, which is, those are vastly different expressions. I mean, this is only 1/6, and this is like 1 plus stuff. So nope, not a thing. I mean, if you hatch rules like this in your head, just try them on normal, regular numbers and fractions and see if they see if they actually work. So, because if they don't, then right. I mean, this kind of thing works if you are splitting up the top of the fraction. But no, you can't split up denominators like that. So careful with that. But let's try to just multiply it out, right? Because we know that b plus r is just multiplied by b plus r, b plus w. And then same thing on both sides. So I'm just gonna crowd it over there on the left. That's there. Okay. If we do that, then we get r times b plus r is greater than w times b plus w. Because you get canceling of the other stuff. Those are out. And those are out. All right, well, now we're talking. Do you notice that this is the same formula? Except you got the r in there, here, and you got the w here. It's the same formula on both sides. So basically what you're saying here is the same formula with r is bigger than the same formula with w. What does that mean? It means that r is greater. I mean, can you solve that algebraically? Not really, at least not in any obvious way that I see. But you just think about real life examples of this, right? Like if I say, I don't know, 20% of my income plus $17,000 is less than 20% of my brother's income plus $17,000. I mean, that just means he makes more money than I do. Is what it means. So, yeah, the same formula. So you're right. You can also do that there, but you can also just multiply that out, which you could legitimately do with algebra. So you could make the same realization here as well, but you don't. Unlike here, you don't have to, because that you actually can just multiply out on both sides. So, but yeah, right. These are formulas. I mean, this is everything positive and plus and multiplying and stuff. So the bigger the thing he gets in the blue boxes, the bigger the formula is going to be. So this means r is greater than w. So that's the only thing, and you're not going to get. That's going to be. You can only get that, and that's not a thing that you can get. This is sufficient. Bet you it is. Any questions about that? It's a thing. You can do that. You can also conceptually too. You can, if you look at the original formulation here, you can realize that that's R over others versus W over others. If you just think about that for a second, the more you have of something, the bigger that ratio is going to get in versus everybody else. So that's more, slightly more conceptually involved. But if you make that realization, then you're going to be good to go there. If not, you can just fall back on this intuition that you can have about making data sufficiency problems. Like, yo, dude, someone's going to have to like make that up at random. Well, that's not a thing. It's not a thing that happens. I mean, where am I going to get a statement like that? Gotta get it from somewhere, right? So we got a alligator for this sucker. Any questions about that problem? It's a neat little problem, huh? Good stuff. We have time to do one more here. Let's do one. Let's do one more. You're welcome. About this last one right here. And you know the drill, you know where the multiple choice answers are found. And there's a lot of words, but you know, it shouldn't intimidate you when there's a ton of words. You should just process them as normal. So the only time lots of words would bother you is if you have this silly idea that you have to solve every problem in 2 minutes or less, which is a very silly idea. Don't think that. You struggle with what? Well, of course you would. I mean, 2 minutes is an average. You know how averages work, right? Averages have as many data points above them as they do below them. I mean, there should be almost as many problems that take more than 2 minutes as there are problems that take less. So, I mean, trying to solve everything in 2 minutes is an absolutely horrible approach to this test. I mean, you'll get killed. You just won't finish any of the long problems. Nope, won't happen. Then you'll just sit there staring at the shorter ones. Yeah, classrooms are weird places. I mean, in the real world, nobody in the real world anywhere outside a classroom would think, I have to do everything better than average. Because people like know what averages are. But then classrooms, man, they're weird places. Weird. Okay, also a public service announcement, guys. Tell me a story about answer E. Just tell me about that. No way, don't do it. Are you freaking kidding me? What? Really? Yeah, no. I mean, not even because it's too high, but because no problem on this text is ever that easy. Like, literally not ever, not even sort of. Like, this is another thing. Like, let's say that you don't even read English. Like, let's say that you have, like, a problem that's like, blah, 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 blah. Well, thank you for posting that right in the middle of the public chat. Okay, everybody don't look at that. Let's say the problem looks like this. Okay, that's the problem. There's a lot of things that are not the answer to the problem no matter what. Right? If there's a 3 here, and there's a 2 there, a whole bunch of things that are totally not ever going to be the answer to this problem, such as not going to be 5. It's not going to be 3 minus 2. It's not going to be 2 over 3. It's not going to be 3 over 2. It's not going to be 3 times 2. It's not going to be 2 to the third. And it's not going to be 3 to the second. So just don't even. If any of these answers show up, just don't pick them. Nope. Just make sure you understand the rationale here. I mean, if this problem was in, like, I don't know how to read Chinese characters, right? If this problem was written in Chinese characters, these are the answers that I would guess. Because I would have no understanding of the problem at all. I mean, just think about that for a second. Are they going to write a problem where you don't have to understand what the words mean? No, they're not. I mean, the first thing is, again, these should be like, whoa, way too easy. I mean, all you're doing is just arithmetic with those numbers. But also, you don't even have to process the word. So again, this is article of faith if you want, but the answer will never be some like simple arithmetic combination of given numbers. It's not going to be, like, if you ever just pluck 2 numbers out of the problem and just like add them or multiply them or something, nope, not going to be right. Because they're going to give you a problem that you have to actually understand. So like here, if you're just like, blah, 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 3 songs, 0.3, right? I mean, nope, don't even. Don't even think about it. Don't do it. Nope. As long as we're at it, there's another don't do it answer. 3 of y'all are picking it. Which one's the other don't do it? Yeah, so I mean, this is just 0.3 times 0.3. I mean, it's also kind of a ridiculous answer too, but it's not going to work like that. Nope, not a thing. Don't do it. Also, just common sense, but we'll get there in a second. So, give it a shot. All right, let's discuss. What about just plain common sense? I mean, there's a lot of words in this problem, but just make sure that you know what is happening here, like what's actually going on. So, well, all right. And we have the first station. Got 30% chance of a win here. And then if not, then we go to station 2, which is a 30% chance of win if station 1 was a loss. And then if not, you lose that one too. Then you turn to the third station, which is a 30% chance of a win if both station 1 and station 2 were losses. Yeah, okay. Common sense, y'all. Which 2 answers are just totally not even making any sense right now. I mean, consider that right there. You flip to the first station, there's already a 30% chance that you're happy. Already. First time you flip that radio on, you're already at 30%. So, yeah, I mean, not A and B. Of course not. Because, you know, the point is that you're already at 30%. And there's a whole bunch of stuff that happens after that, which is only going to increase the chance of success, right? Like if you know, 30% straight off the top, 30% chance right off the top. That's in this color. And then even if you don't win right off the top, you have basically more chances to win. So it's got to be more than 30% because it's 30% plus second chances. So no matter what, it's not A or B because A and B are not even 10%, much less 30%. So those are goners. I mean, A is also a goner because A is like, don't do it. Don't just multiply those numbers together. But, yep. What about pure intuition here? Notice that you've got 30% chance right off the top. And then even if that doesn't win, you got 2 more stations that you can go to. Like choice C would mean that those 2 extra stations would only add 11.7 more percentage points. D would mean that those 2 extra stations would add 35.7 extra percentage points. I mean, again, this is not, I wouldn't call this necessarily pure common sense anymore, but this is still well within the domain of think about the numbers and what they mean, right? What you should realize is that these second couple stations are going to give you pretty decent extra chances. I mean, there's no way that you're just going to get 11 extra percentage points out of that. I mean, it's a little intuition for numbers there, right? But you know, with two more stations, the probability should certainly jump by more than this, by more than 11.7 percentage points. It should, right? I mean, just shouldn't make sense to you if it only went up by that much. So if you have that kind of intuition, then you should know that we're looking at this. How about that? All right. Any questions about that? Notice that if you have this combination of common sense and some numerical intuition, you can backdoor the entire problem like that. It's kind of neat, right? Let's talk about calculating it. Here's a situation. That's so big. All right. Doesn't make any difference which one is faster. They're both things, and they both work, and you don't get style points. So, point is just to collect as many methods as you can. Like really, do not think about this stuff, ladies and gentlemen. Nope. If you want to lower GMAT score, this is the best way to get that. Yep. Thinking about stuff like this. Is an excellent way to score lower on this exam. Yes, it is. Probably the best way to score lower on this exam, if your goal is to score lower on this exam. It's a great way to do it. Because what this will do is this will make people not do things. That's what it'll do. Like if you consider this, like this problem that we did before here with, okay, this one right here. Like people who think about stuff like, oh, is this faster or slower? The problem is that those people will just sit there and wonder whether there are faster ways instead of just doing stuff. You know, the people who are not worried about that will just start making this list and then we'll get this problem correct. The people who are like, oh, is there a faster way? They'll do nothing. They will do nothing. They will just sit there and stare at the screen and wonder if there's a faster way. Bad look. Don't do it. I mean, just anything. You just throw stuff at it and see if it works. So you should never think about faster or slower. No, don't do it. Not the road to success there. So yeah, don't think about that. It's not a thing. You just want to do stuff and don't not do stuff. But okay, I mean you can calculate this directly, right? Sure you can. Move these guys down a little bit. We're gonna fast forward this a little bit. I like have a tight schedule here, so let's just do this quickly. If you want to calculate this directly, you just have to, these are all separate outcomes, so you just calculate them and add it up. This is going to be 30%. Sure it is. Okay, here you have to have a loss for the first station, and then you have to have a win for the second station. So you have to lose first. That's 0.7. And then you have to win on the second station. So that's 0.3. So far we got 0.300 and 0.210. Now notice, I mean, at this point, with these answer choices that we have, let's bring these choices in. There's the choices. And with these answer choices, you're kind of done already, right? Because you know that it's going to be more than 51%, but it can't get all the way up to 90%. So as soon as you get here, you're done. Because you're already bigger than A or B or C, and it's not going to be E because you can't gain 40 more percentage points. No, don't do more work than you have to do, right? When you review the problem, you can work out the rest of it. 0.7 times 0.7 times, and then 0.3 for your win. But there's no even reason to bother doing this with these choices because you're down to one choice after those first two. But here, this is 0.49 is approximately 0.5. So that's about 0.5 times 0.3. So there, you have a total of approximately 0.6. That's a thing, you can do that. And then finally, Andrew J, if you're still here. Andrew J is not here anymore. Notice there's so many ways of doing that. But we can just talk about reverse method, right? What's the only way in which this doesn't happen? Like, if this doesn't happen, what's the only way to not win? Yeah, the only way to not win is lose, 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 right? Lose on all three stations. So this is 0.7, 0.7, 0.7, which is approximately 0.5 times 0.7. So that's the only way to not win. So the probability of win is approximately 1 minus that. Neato. Good stuff. Cool. All right, thanks for sticking it out here with us. We gotta close the curtains here for now. I want to say there's actually another session next week too, because we had this hiatus in between. I think maybe, although maybe not. I don't remember. It's either next week or the week after next. So one of those weeks. In any case, thank you very much for coming today and attending the session, and we will hit it up again next time. Either next Thursday or the Thursday after, it's one of the two. check it out. It'll be posted on the web in very, very shortly. So, and that's it. All right. Thank you very much. Kill the recording. Good evening, good afternoon, good night.